what I enjoy the most about it is that it's a constant evolving sort of thing, and it's directly relatable to the planet that we're on.
Our guest today is Greg Hall. Thanks a lot for joining us.
Thank you for having me.
Welcome to the podcast, Greg Hall. I will tell our listeners that you are Stantec's industrial sector leader for the buildings group globally. So tell us a little bit more about yourself. How did you get into this? What kind of projects do you work on? Where are you based? And then I'd love to get a little more into the nitty gritty of projects and sort of your recent experience. But yeah, tell us a little bit about yourself first.
Oh, great. Thanks, John, for having me today. Really appreciate sort of carving out some minutes today to talk about sort of what I do. But who I am, again, I'm Greg Hall. I'm the VP for Industrial and the sector leader for Stantec. And what that means is that I'm responsible for all of our business lines within industrial space, which includes advanced manufacturing, which is what we're going to talk about today, but it also talks about, we also do industrial designs for warehouse distribution, maintenance facilities, food and beverage, bioindustrial, a whole breadth of different type of processes. But one of the big things that one of our big markets is advanced manufacturing, which I think we'll define at a later minute here during the podcast. But from my day to day, I'm an architect. I've been in the industry for close to 25 years. I've been with Stantec 18 years, based out of Pittsburgh. But when I say based, it means I travel around quite a bit. The company and all of our industrial hubs are scattered throughout North America, and especially all the global work that we're doing right now. So I try to stand still as much as I can, but I'm often traveling and meeting with all the people at Stantec and hearing about their exploits and what they're chasing, and of course meeting and taking care of all of our clients. So, but today I'm glad I'm sitting here speaking with you, and hopefully I can sort of unravel the mystery of what advanced manufacturing is, and sort of like the projects and innovative sort of approaches that we're taking, and what sort of sets us apart from everybody else in our business. So again, thanks for having me.
Great. Yeah. No, we're excited. So let's start from the beginning. What is, when we say advanced manufacturing, what are we talking about? What does that term mean? Because I feel like it's maybe not so well understood. It took me a little while. I remember a couple of years ago, I was working with you. It took me a little while to sort of get my head around everything that encompasses. But what does it mean when we say advanced manufacturing in 2025?
Right. I think saying 2025 is important. So it's a term that within the industry describes three major markets within manufacturing, and those being EV batteries, semiconductors, and solar panels, and also some of the soft peripheral type of processes that support those three big industries. And a lot of it comes out of similarities within the manufacturing process, but also the fact that they are all interrelated in sort of diversifying energy and computational control and power. So having those three sort of markets and industries, you see a lot of relatable sort of requirements. When I say requirements, like resource requirements, meaning that they're very heavy on water and energy consumption, but they're also sort of all related to most of the industries that they apply to. So when we talk about advanced manufacturing, remember it's EV batteries, solar panels, and semiconductors. So that's the main focus of what advanced manufacturing is.
Got it. Gotcha. And why are we talking about it? I mean, is this something that we're seeing more of in North America and Europe? I know when we used to talk about those industries, they were happening in other places, but it's not so much true these days.
I mean, we're seeing it. It depends on where you stand, but we're obviously seeing it in North America. But it's really a global trend, and it's a bit of shifting of manufacturing processes and where we acquire resources and where we decide to build our products. Everyone's aware that the United States is one of the largest consumers, or is the largest consumer in on the planet, and over these past couple of years, there's been a lot of shifting, especially within geopolitics of basically national security when it comes to energy, and also the focus on energy transition. So, as these manufacturing projects or products have been typically done offshore in foreign countries for economic reasons, we've seen, especially in the 2019, 2020, that national security and having access to having those things is very important for an economy. So the trend is, and I want to say it's a bit of a deglobalization, but sort of actually pulling a portion or all of those manufacturing products locally to the United States. So the term reshoring, I'm sure you've heard, is what that is. And we want to be able to not only have control or domestic availability, but also sort of control the market as well. Because having solar panels to drive certain alternate energy sources is hugely important. But also, semiconductors and having computational chips basically runs everything that we're consuming. So anything from cell phones to cars, we saw a lot of disruption with vehicles in 2020 and moving on. So having these things domestically is very, very important. So that's where the trend is, and other countries are the same way. So Europe is wanting to have their own battery manufacturing and semiconductor chips and all of those things domestically and locally.
Great, yeah, and a lot of this is is inspired by these supply chain issues that we saw during the
Correct.
pandemic
Yep.
as well, where we realized, okay, not being able to get these semiconductor chips means we can't actually build cars. There are things
Correct. Yeah.
that we weren't even thinking about because
Right.
the global interconnections, and when those interconnections are disrupted, it's highly disruptive. So I think that's part of it, is sort of a economic resiliency effort.
Yeah, and it's interesting because you really don't realize that, we'll talk about cars here, not to get too far off on a tangent, but like just the raw material supply, right? Like, understand, do we have steel availability? Do we have certain plastics? Do we have certain things? So when we're highly reliant upon having that thing ship across the ocean, and all of a sudden we don't have that, what do we do as an alternate? And it very much exposed a lot of cracks within our distribution chain and our resource availability.
Yes, and so you mentioned Europe. That's kind of that was sort of a surprise to me, or something that I hadn't thought about. I mean, new reshoring was happening here. Is Europe sort of playing catch up then? How is that similar or different from what's happening in North America?
Well, I think the consumer trends are slightly different, and I think Europe is sort of one of those regions of the world that sort of is ahead of the United States. So when you start to see the EV market strengthen or become soft, typically United States follows suit, quickly after. So in a way, keeping things on Europe and how they're reacting to the markets and things like that is sort of a clear indication of what's about to happen in the United States. So, I use the EV market or the EV battery market, but certainly Europe relies upon a lot of sort of the resources that we're providing them and back and forth. So it's something that's that we keep our eyes on, and especially we have a lot of projects in Europe and also in Germany and all the other related countries. So what happens in Europe is eventually going to happen in the United States. So they're very much interrelated quite a bit.
Mm-hmm, mm-hmm. So we're talking about all this from a buildings perspective, right? We're talking about advanced manufacturing. We're talking to you, an architect, about advanced manufacturing. what makes an industrial building that's suited for advanced manufacturing different from sort of a typical industrial building?
You have to understand that these buildings are designed from the inside out, right? So they're very much process driven, and they're very much process driven with designing in a big room with our clients and our contracting and all of our subconsultants because of its process driven. A lot of the times, especially within the semiconductor space, the process lines and or what they're building isn't known until the building is almost complete. The processes are very complicated and they're constantly evolving. So therefore, the requirements of cleanliness, energy consumption, chemical types, chemical flow rates, all these sort of things that go into sort of making these products is sort of in fluctuation. So um, you know that is one of the biggest things or the biggest considerations when working on projects like this is that change is inevitable, and having a good handle on how you mitigate change during the process is extremely important for our clients. So I think that's one of the differentiators among some other things where we may have some industrial clients and they'll come in and say, well, this is what we need. This is the program, and we can sort of work through and move those components where within the advanced manufacturing space, the technology is truly on tip of the spear. So, we may talk about it as semiconductor, manufacturer that's working on a 5 nanometer chip, and they don't have the tools or the equipment that actually exists yet, and so therefore we're helping them move ahead in working on assumptions and being able to kind of pivot when those knowns are known. But when it comes from a planning standpoint, there's a couple things that are always going to be paramount, which is, the level of cleanliness within semiconductors. What are the ISO certifications that are possible? How do we provide and procure equipment that's in high demand to help our clients reach their goals? So there's a plethora of all these different things, but we always have to have our ear open to see what they're pursuing downstream, so that we can help them provide solutions. So when it comes time to open up the plant, that not only do they have something that's actually facilitating what their goal is, but it's also scalable, because we know it's actually going to expand and become different after the plant is operational. So I think change and the level of complexity that goes into it really sets apart the advanced manufacturing process, and it's something that experience really does matter. So that's one of the biggest differentiators among other sort of industrial projects. And every industrial type of project has their nuances, but it's a little bit more sophisticated because of the hazardous material and the chemical list and the cleanliness necessities that are needed for this.
Give us an idea of what goes into that or what level of cleanliness we're talking about. I mean, I that's something I think people would be interested in, like how clean is a clean room? What do you need? What do you need to make it a clean room?
Right. So, I mean, these chips are very susceptible. If there's any sort of particle or something that goes that actually contaminates the chip becomes bad. So when we're talking about ISO ratings, for someone that's not aware of ISO ratings, they go from ISO 1 all the way down to 9, 9 being the dirtiest, ISO 1 being the most clean. And by far, an ISO 9 is not a dirty room. It's cleaner than all non-certified rooms. But an ISO 1 is a room that has, it could potentially have, 300 to 500 air exchanges per hour. So, there's a constant flow but you're not creating wind or things like that. It's just a level of cleanliness so that particles and things are not being contaminated onto the surfaces or the manufacturing process. So, the certification in these giant rooms that are the central sort of core of these facilities are incredibly important. And then also due to the level of sophistication of some of the processes that are going on, we have vibration, and that vibration not only of the equipment but also within the environment. is important. So if you think about air exchange and wind and all these sort of things, keeping things sort of isolated so that while you're creating something at the nanometer scale, nothing can be disruptive on that chip. So it's just sort of an indication of the scale at which the science that's happening is just phenomenal. So having extreme control over the environment, the humidity, the vibration, all these things sort of are intertwined. So us as architects and engineers have to understand how to isolate and achieve those specifications so that the products that are coming out are at the level of expectation and what's needed.
Great. Something that you mentioned, I think, during one of our other chats, but that seems to me is also really interesting about these is that the time scale and the sort of schedule aspect of them is really critical to their financial success, right? If these places don't open and begin operations when they're supposed to, it's going to cost somebody a lot of money.
Right? A lot of money.
Yeah. And it's sort of, and at the same time, like you said, the whole thing is evolving while you're working on it. The technologies are being developed in parallel to the factory. What are some of the ways you approach this that help this kind of design that helps meet that sort of day one operational target? Is there a way you think about sort of a headspace you're in, or is it about getting certain fundamental things done first before you do other things? How does that work?
Well, yeah, that's a very complicated question. So I think the easiest way to answer that is that while we do the best planning that we can, we understand that plan no longer exists on day one because we have to be able to remain flexible. And what I mean is that when we structure our teams, when we structure our communication, it's very methodical, and we're keeping a good cadence so that we can track, and so we're not sort of reworking and repeating stuff, because it's very important that while decisions or assumptions are being made, everyone's aware of what's a decision and what is an assumption, so that they can go back and make sure the design and or procurement and or everything else is moving in a positive direction. If we could work in a vacuum and have any material or any product or any piece of equipment available, that would be an amazing thing. But it's not true, because of the boom of the advanced manufacturing and the semiconductor world, there's shortages of certain types of material, certain types of equipment, labor, who can actually do these facilities. I mean, there's only a handful of people on the planet that can actually design and make these facilities. So everything's in high demand. And then I think where the innovative portion comes to it, and this is all sort of going back to, hey, this business needs to open up on time. How do we achieve that? So, going back to my point, remaining flexible, looking at the palette of what we're working with, and then being able to pivot and work and use what's available to achieve the same results. And what I mean by that is, as an architect, we're responsible for shelter and shade, right? The engineering, we keep the water out, right? And we keep the life safety so that everyone's safe inside. Our engineering team is making sure that all these things and everything flows and everything works when it's supposed to. And then when we bring in our water group from Stantec, they're building the machines to scrub and do all and sort of recycle the water. Now, a really good example of this is there's only a certain amount of companies that build the right wastewater equipment or the membranes to sort of purify this water. And so sometimes we have to look at, well, we can't use this canned solution because we have this mix of chemicals. We have to look at using this this box of parts over here to achieve the same thing. And there's only so many companies on the planet can do that, and our water team does that very well. We can achieve the same results with lesser demand parts than trying to sit there and wait. Well, we have 18 months until we get this part, so we're just going to have to push schedule, and that's not an option. So we're coming to the table with innovative solutions using parts that may be more available to achieve the same results. And it's the same thing when it comes to the building. While a certain method or certain material is not available, we'll use something else to get the same results, on budget. And especially when it comes to piping and things like that. So those are sort of the approaches that we have is remaining flexible, being innovative and looking at our approach, but also maintaining very clear communication and strong practice, and making sure that we're not repeating ourselves and or recycling and doing loss of effort or loss of energy of things, and making sure that everything's sort of moving in a positive direction, because we know change is inevitable. It's not how whether something's going to go wrong or change is going to happen. It's how you react to it. So that's where our teams, I think, our team is extremely strong on, is how we react to something not going quite as planned.
Yeah, you just brought me to something I was going to ask you about, which is that you were talking about how conflict is not necessarily bad, right? On these projects, what's important is that everybody is communicating and allowing for different points of view, or allowing those solutions to emerge in the process, right?
Mm-hmm.
Is that part of this? Because obviously, if you're encountering situations where, hey, we don't have the right material here, then you have to be able to sort of advocate for some alternative vision, right?
Right. I think we're real selective on our teams, right? So when we're partnering on projects, on pursuits, we're making sure that our partners and our cultures align, right? You bring up conflict. So conflict is inevitable, and it means you're probably having a healthy conversation. But in the end of the day, we have to come to a consensus to move the project forward. So, that relationship that we may have with a contractor in a design build format or with a client is extremely important, because we don't want to march into something that maybe cultures don't align. And I mean that from a corporate culture standpoint, and that and then have problems downstream while we're in the middle of the project. We want to step into a project where we know that we can move and sort of pivot when necessary, but also set up the project to be successful, because that's what we're being hired to do. If the client had all the information and had all the answers, they wouldn't need us, right? So we have to be able to sort of take what they have and what they do know and sort of mold that into something that they can use. And that's why they hire Stantec on these projects.
Great. And I think the other day when we were talking, you kind of alluded to the ability to get everybody in one big room. It's not the kind of project where you can just pop in and do your bit and everybody
Walk
else
away.
runs away with it. You sort of have to constantly be evaluating what's there, right?
Yeah. And those days, I don't say they're long gone, but when you're dealing with sophisticated facilities like this, everyone's integrated, everyone's involved, and it is a big room kind of collaboration, and which is why I think that's one of the biggest strengths of Stantec, is that we are an integrated company, and we act that way, right? So when we show up on a project, all of our disciplines, everybody shows up and is there day one, because I can tell you, while we may be talking about life safety or something from a programming at the initial phase of our project, I guarantee you there's someone on structural or mechanical or within our process and instrumentation is going to have a comment, because there may be something that I don't understand that they do. And they said, well, this is going to have an impact at a later date, so we should be thinking about.
One thing that occurred to me is that some of these clients that you're working with in advanced manufacturing might even be new to North America. I mean, this might be their
Yeah.
first plant they've done in North America. Is
Mhm.
that was that helping them with that learning curve and sort of navigating the ins and outs and the codes and there's a certain amount of we just do this is how we do things here, that
Yeah,
built into
yeah.
working in North America.
No, there's a lot of that. So a lot of the advanced manufacturing and the reshoring of these facilities here in the U.S. They're foreign investors and they're foreign companies. So
Mhm.
it's sort of I think I would say it's sort of how our soft skills it tests our soft skills of communicating to them, saying, while I understand this is how you do things over in country X, it's not quite how we can handle things here. So, there's a lot more regulation, there's a lot more accountability and responsibility to the environment.
Mhm.
There's just not do this because I said so, or bullying or pushing municipalities. There's a certain process, and also, something also to keep in mind is that the equipment is may not be rated, appropriately. In country X that is here. So, if they're borrowing or thinking they can use the same equipment that's non-domestic here and domestically, that's not exactly true. So we try to help them say, well, if you need an underwriter's laboratory rating or something like that, we can help you with the process to make sure that it's legit and it's something that you're not going to get penalized at a later date when you're trying to get the plant up and running. So yeah, it's a bit of everything's sort of in clay, and we're sort of molding it and helping them understand the process. And a lot of these things take several years for approval prior to even start building. You can't buy the property and put a shovel in the ground, right? So the permitting process, we from a critical path standpoint, and again, this goes back to making the project a success for our clients, is saying these are the big chunks of things that you need to knock out in the right sequence to get you on track. So I need to draw your focus to here, and these are the things we need to be doing. So that's from an education and guiding standpoint. That's one of the things where, again, experience matters. You have someone coming in from a foreign country trying to build here. This is what we can bring them, and then it's also keeping in mind that they're typically bringing their own engineering staff. So that's why the big room sort of thing works, right? Everyone's sort of communicating, and it's nothing that we can have a lot of separate conversations and hope that the project marches along, because I'm sure there'll be something missed. So, upfront, a big room sort of approach works well. And of course, having folks on staff throughout the entire construction process is vitally important as well, and
Mhm.
is pretty much industry standard.
What are the areas where these? I mean, it sounds like these say the semiconductor manufacturing facilities. I mean, they're going to be innovative by nature because they're they're built they're built for
Right,
building
they're
things
building computer
that
chips. They're
aren't
building
even
stuff we can't even see.
yeah,
Yeah,
yeah, that's some that haven't even quite been invented yet, but
yeah.
we'll be ready to make in 6 months time. What about we were talking about water. um are are there opportunities to make these places more efficient and safer, and is that kind of where the innovation is on the efficiency and the safety and the environment?
Yeah. I mean, I think there's a huge opportunity for us to maximize, I guess, um, the efficiency, and that's there's so many different ways we could be talking about this. But if you talk about just sort of the resource usage, yes, there's a lot of power, there's a lot of water usage, and so water especially is a finite resource amongst all of our resources. So a lot of the innovation is well, if we're using 3.5, 4 million gallons of water a day, which is sort of on the scale of what we're using here, um, how do we scrub that water and discharge it back into the earth? Is there a way to do it so there's zero discharge? We're constantly recycling the water to a certain point, And so while there's a price tag attached to that, but there's also a return on that, downstream. So um, these are all the sort of the checks and balances of like your upfront costs versus life cycle costs, and then also the impact to the environment, right? So while money has a direct relationship to resources and things like that, but it also has a direct relation to waste and how efficient we can be. So, if we can do more with less, that's obviously better. We all know that, with the technology these days and artificial intelligence and the need for data centers, these data centers create a lot of heat and need a lot of cooling and need all these different resources to run. It's just not magic energy coming from the sun, right? So, I mean, it's being pulled from a lot of different avenues, and using computers takes a lot of energy and all that computational power. So, um, I think that is going to be the biggest problem to solve here in the next couple of years is how do we do this more effectively, right? So there was the big boom and all this work and all these advanced manufacturing, but I think now things are going to start to flatten out and become more of a little bit linear of a growth, and making sure that we're doing that responsibly is going to be huge. So I would like to see a lot more attention to that. And certainly we do it on our part, but also from our clients' end as well, because resource scarcity is certainly going to be a subject here in the future.
Great. So what do you like about these kinds of projects? What does it mean to you? What are the what inspires you to get up in the morning and is it the ability, the chance to like solve problems, and is that the part you find satisfying?
Yeah, I mean, it depends on what day you ask me, right?
Right.
No, I mean, it's not easy, right? And there was points in my career where I started to feel content, and I didn't feel challenged, and I felt comfortable. And I've never, I'm in my mid 40s, and I don't think I've ever felt comfortable in my life. And when I do, it's an uneasy type of feeling. So what I enjoy the most about it is that it's a constant evolving sort of thing, and it's directly relatable to the planet that we're on, right? So when it comes to talking about, hey, how am I making an impact? The projects that we're working on are having an absolute direct impact at a very, very large scale. So if you want to help people, this is the best way to do it at such a large scale, because the need and the consumption is not going to go away. So how can I do this better and make a larger impact? And it's very exciting. I mean, the clients that we're working with are world class. They're bringing to us a knowledge that um, many people don't see, and we get to work on these exciting projects that are just phenomenal. And I think the hardest thing that I have in my position is that we can't talk a lot about it, right?
Right.
It's very confidential, and it's sort of like, well, who are you working with, and what are you doing? And it's like, well, I can't tell you, but I tell you what, it's incredible, right? And the things that we can talk about, I love it when we get onto a project where it's very open, it's very public, so then we can sort of give a window into what we're doing. And one of those projects, that we won a couple of years ago, and getting close to wrapping up, was the Project Redeemer down there in Georgia, which was it's the largest solar panel manufacturing facility in the northern hemisphere that took an innovative approach of putting all four processes under one roof. And this is something that hadn't really been done before. And when I talk about solar panels and semiconductors, the processes are very similar. Semiconductors being much more constringent upon controls, but we're still basically making computer chips and products out of sand. So it's the same sort of process. But that project was great because it was something we could talk about. And while we can't show photos of the inside, we can sort of talk about in general terms of what we achieved. And it's been a successful project. And great client, great contractor. It's been one of the pinnacle projects here at Stantec. So I was really happy to be an important part of that.
These factories are so interesting, right? Tell me
Yeah,
how you think about these places.
right. We just started talking about what's actually occurring inside of these boxes. I think I use the analogy of the Manhattan Project. The level of sophistication of science that's happening within these manufacturing cities is like is just profound. I mean, the things that they're worried about are at the nanoscale. They're worried about things that are like physics, right? Like electrons jumping from one circuit to the next. That's the scale at which these folks are working at, and all of these clients are all sort of like racing to this end goal, which they know that the science and when they achieve it is going to change the world. So it's just phenomenal of the type of things that are occurring inside this and inside of these boxes or these facilities. And I truly have a great appreciation for the amount of work and diligence that's happening, from on our clients' end and sort of what's happening. It's just it's like budding physics and science. We're right there, and it's a great place to be within the industrial sort of revolution.
Yeah, I mean, you could argue like this is where the future is being made, right? And it's
right.
Not out in the open. It's not a well understood sort of place because by its nature, it's proprietary technology and proprietary processes and very competitive world. And we for us it almost looks like science fiction, but it's not. It would look like science fiction if we knew what it looked like.
Yeah,
but it would be mind blowing, I think, for a lot of people to see what these places look
like. And when it's all said and done, people look hindsight and it all makes sense. But right now, it doesn't make sense, right? We're sort of going on these paths and sort of figuring out along the way, and we'll get there. But it's really truly is carving out the future of what we're going to be doing, and it's so immensely important. And it's being a part of that is it's just incredible. I wish I could share with you some of the things I've seen, and sort of where things are going, but I can truly say that it's phenomenal.
Well, Greg, what we'll do is we'll just say that you're the guy that gets to go into the future and see what it looks like, but you're not allowed to come back and tell us what it looks like.
Exactly, because if I tell you, it's going to modify how things end up. So
right, exactly. It's
the butterfly effect,
breaking the time traveler's code.
Right.
All right. Well, thanks again. Thanks for coming back for a little bit more, and we'll definitely have you on the podcast again. Appreciate it.
Absolutely. Okay. Have a great day. Thanks, Don.
Thanks.
Bye now.